Today, I'd like to speak with you about reading the unreadable and how state-of-the-art technology can have a positive impact on the food industry. Shortly about myself, my name is Jan Gärtner. I joined MVTech around 4 years ago as an application engineer, and since 2022, I'm the product manager for Helken, our flexible machine vision software solution. I think we are all loving to have a full fridge, so we can choose every day what we want to eat next, and we have the full flexibility. But on the other side, having a full fridge can be a big burden, because all the time we have to check, is the food still good, or is it after the expiry date? As a human, we are lucky, because we can always use our senses like smelling and tasting to check if the food is still good. But in the industry, it's a way different challenge. Because when food gone bad in our own fridge, we throw away maybe one banana or an apple. In the food industry, we are probably throwing away thousands of bread rolls because they are gone bad. And for this reason, quality inspection and tracking of process data is really crucial. And continuous tracking is quite important so that we know when something is going wrongly, so that we can apply countermeasures to keep the quality high in our production line. Keeping the quality high, meaning reducing waste and also reducing costs in conclusion. In general, in the food industry, more than 90 million tons of food are wasted every year. And I think it makes sense to reduce the amount of waste and also reduce the costs. And in the food industry, this problem is not easy, because there are quite a lot of requirements when you want to use machine vision for the inspection. First of all, when you're using machine vision, you want to make sure that no defect product leaves your production line. Meaning you want to find all defects, because otherwise you might have recall campaigns, lawsuits, or in worst case, health issues for your end customer. Secondly, you're most likely producing thousands of goods every day, meaning manual inspection is not a solution for you, and you want to automate your whole production line. Also, due to market trends, the packages of foods or products are nowadays changing all the time. So sometimes we have a red box, another time we have a green box or transparent box. And so we need a flexible solution that we can customize based on our current product within a short time. And last but not least, as we are producing thousands of goods, we need short cycle times for the actual inspection. And our goal is to get like a near to real-time tracking of our production data and quality data. But today we want to speak about OCR. Object Character Recognition. OCR means text reading. And text reading is really important to track your quality data. What are the requirements for text reading in the food industry? We can see here we want to have a flexible solution. So we want to read texts no matter how the package does look like. We want to have a text reading solution that can read all text and not just a small subset. And we want to have a solution that is really, really fast, so it doesn't slow down our cycle times. For the image you can see here at the bottom right, we think text reading is quite simple. But there are way more challenges for text reading, or more complicated challenges in the food industry. Starting from, we have many different fonts, like for example, dot printed fonts or text on various packages. We often have to deal with reflections, for example, on aluminum surfaces, metal surfaces, or transparent backs. We have perspective deformations, meaning we never know exactly where a product is on the conveyor belt. It can always be in a slightly different position or orientation. And last but not least, we have to deal with local deformation. Local deformation when we have flexible packages, and these are quite common in the food industry, so they are always slightly deformed. And these slightly deformed reflective surfaces are the hardest to read. Our solution for this problem is called Deep OCR. MBTech was founded more than 25 years ago. And 25 years ago, mainly rule-based algorithms had been used in the machine vision industry. So these algorithms required a lot of parameter tuning. You had to segment the characters, configure your classification network, and this was really, really time-consuming. Now, in 2024, we are many steps further, and we have now a deep learning-based solution for this problem, requiring less parameter tuning and making text reading, object character recognition more easy. To show you how this technology works, our Deep OCR has two submodels. The first module is called the detection module. There you give in your actual image where you want to read the text, and this model is looking first for all the characters. It's a pre-trained model, and then later on it's linking or connecting the characters together to words and sentences. Once we extracted all the word regions and character regions, we then forward the output of the detection model to our second model called the recognition model. And the recognition model actually gets the bounding boxes, so rectangular boxes, from the detection model and reads all the text inside these bounding boxes. And this technology works very well, and works really well especially for the food industry. And there are various reasons for why it works good. The first one is it works independent of the position and orientation of the actual object. As mentioned before, objects always can be in a different position, but with the Deep OCR, we can find text anywhere on the image. Meaning, even if the machine does slightly change, you don't have to adapt your algorithms, because the text is still found on the image. Secondly, we have a really model trained on a really wide data set. And for this training, we used many different images from various industries, starting from text printed on different surfaces, text that is engraved in an object, or stamped into, like we know it, for example, from a can, where a beer can and its due date is printed, stamped inside. So we get flexibility, and the text can be read no matter what font type we have. Last but not least, we have a model that is trained only on in-house data, meaning we acquired our own data set and trained the model, and additionally we used images that are licensed for commercial use, meaning you don't have to be afraid of any copyright violations. No, only legal data is used to train the model. Because nowadays it's often a topic with all the generative AI models. Are they legal or are they not? With the Deep OCR, you can be sure that this model is legal to use in commercial environments. But today we want to speak about reading the unreadable. And what does the unreadable look like in the food industry? In the food industry, one big problem is when the actual text looks really similar to the background. So we have a high noise, low contrast environment. And our solution for that is fine-tuning the actual model for the specific data set. So you always have the choice. Do I want to use a generic model provided by MVTech, or do I want to fine-tune a model for my specific use case to perform better? And with the fine-tuned model, you can also read really difficult text like the one here in the high contrast environment. And when you are an international company, you're maybe facing another problem as well. Maybe you're working together with a Japanese supplier. And the Japanese supplier sends you products. Those products have an expiry date. And this expiry date, unfortunately, is in Japanese. And this character is not included in the generic font, but you still have the option with the fine-tuning to train your own characters and to extend the character set of our generic model to whatever you want. And really nice here is, as our model is really generic by default, you only need a few training images to extend and add additional characters. Let us have a look how the whole training does work. Here, basically, we are following the standard deep learning workflow. So nothing new, nothing special. We have 4 steps: preparation, training, evaluation, and inference. Inference is meaning the execution of the actual model, could be the generic one, or could be the fine-tuned one. The 3 steps before are the actual steps that are required to create your own model. So you need your own training data, your labeling or annotating your data, training a model, and later on checking if the performance of the model is good enough. And what's really nice here is that the first 3 steps, which are really user-centric, so needs a lot of user interaction, can be done in our so-called deep learning tool. The deep learning tool is a program who streamlines all the user interactions for your deep learning project, meaning you can really easy label your images. Immediately you get suggestions like what the default model or generic model is finding inside the rectangular box, and then you only have to correct if there is a mistake, and then later on you can use this labeled training data to train a new model and get an even better performance. So with this fine-tuning, we can solve almost any character recognition problem. So we can read even the unreadable. But once you are starting to create your machine vision solution, you maybe think at the beginning, I want to track this package, I want to identify where it is in the factory floor. We maybe after a short time realize we want to do more. And it's not just that we want to read text. We maybe also want to find defects. We want to read the code on the package and way more. And here, it's great that the deep OCR is just one feature in the whole image processing library, the MVTech Helken image processing library. So we can calibrate our image with this library. We can read the text, find objects, and find defects. So we have a really flexible solution. Flexible meaning as well, you can use this library with various programming languages, so using C, C++, Python to interact with. You can use our integrated development environment to speed up your rapid prototyping. And out of the box, there are various interfaces that are required for a machine vision solution in the industry. Starting from image acquisition interfaces for GigiVision, USB 3 vision out of the box. Then we have various AI accelerator interfaces, because before we spoke about deep learning, and usually deep learning is not fast enough on a CPU. So we offer interfaces for NVIDIA hardware, for Halo hardware, and other hardware suppliers. Last but not least, also input-output interfaces are included in this library. For example, OPC UA, a communication standard to communicate with other machines. Altogether, the whole toolbox will enable you to increase the quality of your products and reduce the cost. Reducing the costs through reducing the waste that you are producing and also automating more inside your factory. Meaning, the flexible toolbox enables you to lower the cost that you have to spend inside your production line, and in conclusion, it will help you to reduce the waste produced in the food industry. Thank you for listening. If you want to learn more about the image processing library Helken, we are right over there at Hall 8. We have our booth there. We also offer application tours 5 times, and we have a get-together if you're still here tomorrow afternoon. Thank you.
Thank you, Jan. Very interesting. Any more questions about deep OCR reading?
There is also a tool called Tesseract from Google. How do your solution compares to the ready-made stuff from they produced?
Yeah, I think we all know this text readers that we already have on our phone. So often these text readers are, like our text readers are especially trained on industrial data, so objects that are often used in the industry, and we are offering an offline solution. So often when you have a Google solution, it's running in the cloud. That's another option. Maybe there's also offline options I'm not aware of, but most of the times we have like an offline option that is dedicated, trained on industry data and with no copyright violations.
Thanks. Any more questions? Well, I have one. Maybe you can reflect a little bit on the hardware, what is necessary to run this, on the hardware, on the processing hardware, what is necessary to run this software library.
In general, this software library is really flexible. I think that's one of our core arguments and unique selling points. So by default, it's running on Windows and Linux, also on ARM-based devices. So no matter what kind of embedded platform you're using, Helken will run on this platform. So the big goal of our product is to have a flexible solution that works no matter in what environment.